Welcome to all attendees of the noon session, session 2 of the StepUP closing events. In session 2, we will introduce to you the plug-and-play technologies. Moderator of the session is José Sevillano. José is construction business developer manager at Eurecat. So José, please go ahead.
Good morning, everyone. Thank you for your presentation, Miguel. It's a pleasure to be here today and introduce Session 2 plug-and-play technologies, where we can see how these technologies, from energy storage to the industrialization of construction solutions and integration of different constructive elements, can contribute to the renovation buildings. Next, we will hear from our speakers, starting with Zoltan Andrassy, who will talk about the heat tank flexible thermal battery for increased energy efficiency. Zoltan holds a PhD degree in energy engineering from Budapest University of Technology and Economics. His thesis was the research of the application of phase change materials. Zoltan is the co-founder and CTO of Heat Ventures. Welcome, Zoltan. The stage is yours.
Welcome, everybody. Let me talk about the heat tank flexible thermal battery solution that we fine-tuned during the StepUP project. I will be speaking about the challenges that we are solving with our solution. I would like to show the parts of the technology, how heat tank works, some of our references. Later on, my colleagues and partners will speak in more details what happened with the pilots that we delivered within this consortium, and another one, how we can move forward and what is the, let's say, future or opportunities. So the challenge is simple, and I would like to focus on the cooling when I'm holding my presentation. So the challenge is simple. Cooling is not a luxury anymore. It means that we would like to cool our cars, all of our buildings. We are building ski resorts in deserts. So there are a lot of challenges, cooling and other energy challenges as well. The external temperature is increasing, which also generates more and more needs. The main problem is that heating and cooling systems need to provide energy, heating or cooling energy, when it is needed by the building. And with the storage, we can help the systems to work at the most efficient operation points and not provide the needs when it's needed. And basically, by this optimization in time, with the help of the storage solution, we are able to save energy for the clients. We are able to integrate renewable sources, waste heat sources to the energy mix, which increases the energy efficiency and lowers the costs. This is a very good part of the deep renovation project and ideas. Heat tank consists of three main parts. The first one is the thermal battery structure. This is basically a special heat exchanger inside an insulated box. The phase change material is filled around the heat exchanger, and through the heat exchanger, it is able to freeze and melt during the heat storage processes. We always use materials which are not toxic, not dangerous for the environment, not flammable, and have a very big stability, which means that their lifetime is more than 25 years. So this is a long-lasting solution, providing benefits for the clients and for the building owners and operators. The third part is the control system, because this is one thing that we have a technology that we can use and utilize. On the other hand, we need to make it active to actively help to the systems where we integrate it to save energy or to provide additional benefits for the clients. So the control system through sensors and measurements can support the system operation by charging and discharging the heat tank at the right time. The first part is the structure. Here you can see standard system elements, standard sizes of our product. Those are also what we use in the pilot project. You can see that we have different sizes, mainly the 25 and 50 kilowatt hour versions. All of the storages are quite small in size, which means that it is easy to move them around. It is easy to place them at the location, can fit through a normal door, can fit in an elevator. So basically, it's easy for refurbishment or retrofit projects or deep renovation projects to add these storages to existing heating or cooling systems to support them. We also have a larger product which is under development. This is a 20 feet container version for industrial applications with 1.2 megawatt hours capacity. This is a quite large size solution where it enables also the, let's say, shipping of the heat or cooling energy from one place to another. The second part is the phase change material. This is, let's say, the magic inside the box, inside the black box. During the process, during the heat storage process, we use the principle of phase change, which means that we are changing the phase of the material, melting and solidifying it inside our storages. By the melting and solidification, we can store the heating or cooling energy in a very concentrated form. By a thumb rule, 1 liter of phase change material have the equal energy storage potential of changing the temperature of 1 liter water by 60-80 degrees. So this is a quite large step up in the direction of concentrated energy storages. For cooling systems, we can reach 90% smaller sizes compared to conventional storages, which is for retrofit or deep renovation projects. It's very important to have a very compact solution, because usually all the HVAC systems and energy systems and rooms are quite compact and full of a lot of equipment. So it can be challenging to place a huge water storages inside. The third part is the control system through sensor data, which usually means temperature sensors, heat consumption meters, electricity consumption meters. Our software, our integration algorithm makes decisions on when to charge, when to discharge the storage to provide the biggest benefit to the system. It can also use changing electricity prices, available renewable sources, waste heat sources, which is basically one of the bases of the integration opportunities of our system. And through an example, let me present how it works through a cooling system and what benefits we can bring and what are the benefits we provided to the StepUP during the StepUP pilots as well. So for cooling systems and for every system that we are evaluating, we check how the system efficiency is changing or what are the dependencies of the system efficiency. For a cooling system, when the external temperature is lower and when the partial load is optimal for the cooling system, then we have the best efficiency. So that's a good idea to generate more cooling energy with low outside temperatures, optimal partial loads of the system. And when the external temperature increasing, the partial load is not right, we are able to discharge the storage. To the right, you can see a typical operation for an office building, where basically during the morning time, we are able to charge the heat tank with a very good efficiency, and during the afternoon, when there is the peak need, we can discharge it. Let's see, as in a schematics, how it works. We have the chiller, we have the cooling indoor units. What happens basically without the heat tank, 7 degree goes as a supply to the cooling indoor units, and 12 degree comes back to the chillers. This circulation is ongoing. with the heat tank. If we open the V1 valve, we are able to circulate the 7-degree colder fluid through the heat tank. The material inside the heat tank solidifies. Let's say that the material have the melting or solidification point at 9-10 degrees, so it is able to solidify. Through the pictures, you can see how the circulation is going on inside the heat exchangers. And when the discharging arrives, because there is a need, the V2 also opens, and basically the heat tank pre-cools the cooling water to the chiller, which decreases the power of the chiller, so that we can set up a very good operation point. Again, higher temperature fluid is circulating through the heat tank, which will melt the phase change material. That's how it will give back the pre-stored cooling energy to the system. As references, we installed several heat tanks. We are at around our 40th installations, mainly in Hungary, because we are mainly a Hungarian company. But we are active in other regions as well. We have systems in Italy, Portugal, France, and Spain. The Spain is the StepUP project, actually, which will be in a later topic, and also preparing installations in Oman and Abu Dhabi, because you know that those places require a lot of cooling. And this is quite expensive and not so efficient to cool in those environments. But we are quite active in not just the cooling segment, because we have cooling projects for server data centers, office buildings, hotels, shopping malls, technological processes, but also for heating. We have solutions: gas engine heat recovery, district heating system, hotel heating, or industrial process heating. In the StepUP project, we deliver the storages to the kindergarten of Budapest 18th district, to heating and to cooling solutions, working together with the heat pump, making the heat pump operation more efficient. And in Spain, it's basically a multi-use building, because it has a warehouse, it has office, and it has also a server room, where we are providing very efficient cooling with the help of our heat tank thermal battery technology. We can say that the average payback time for our storages and our systems is 3.5 years. And also there are a lot of support on the market that can be used, because the strategy of the European Union really supports energy efficiency improvements and investments in buildings. So these are also good opportunities to help and to support deep renovation projects, and different locations. It can change by country to country, by place to place, but these are usually quite good equipments and options to have a very good return on investment for the projects. Just a summary, what our technology is capable of. We are increasing energy efficiency in the system, which means energy saving. So energy saving in kilowatt hours electricity or gas consumption. This is important because we are not just, let's say, getting benefits or providing benefit through the changing electricity tariffs, but we have real energy saving in the system. And if the electricity tariff is changing, that's, let's say, an additional benefit for the clients, which is also a very important factor and can be a very, very, very important revenue source with our systems. Waste heat recovery and the green energy storage is also very important, because there are a lot of PV panels out there. There are a lot of technological processes where waste heat is available. So these are the sources that if we can get and use for charging, then later on we can use, for example, coming from so charge the heat tank from a PV overproduction, that we will be able to provide cooling energy when the sun is not shining anymore. So this is an idea, and these are ideas that we can support. As I said, our storages have a very compact size, can be used also for safety backup, which means that for a data center or technological process, if operation security is the #1 priority, if the cooling or heating stops, we are able to provide it while the heating or cooling system starts again. And also peak shaving can have a lot of technological point of or technological benefits, not just energy efficiency as well. Just for the last minute, what is the future? So as I said, we are a Hungary-based company, having a lot of projects everywhere. We are open to collaborate and open to work on different interesting projects, which usually starts with a data request form that we can provide. We are evaluating the needs and the profile, the system type, what are the efficiency points of the system, what are the temperatures that requires to choose the phase change material, and what is the energy price. So we will be able to calculate the return on investment. From the data request form, we can prepare an indicative offer, talk about the details of the system, provide installation guidelines and support, and then later on show the results through an energy report. And that's how our systems are building up. And that's the same principle and idea that we use for the StepUP deep renovation project as well. This was the process that we provided. Thank you very much for your attention. I will be available for questions later in this section.
Thank you, Zoltan. Thank you for your presentation. It was very, very interesting. I take this opportunity to remind you that you have an open channel for asking questions. Feel free to write your questions it. Next, next we continue with our next speaker. She is Marta Lupi, and she will talk about the plug-in and play module envelope system for deep building renovation. Marta Lupi is R&D project manager at Isopan. She has consolidated experience in coordinate cross-functional projects and serve as a reference for fund projects, product development, the management of the company's patent portfolio, and as a support for the marketing department for the launch new products. Welcome, Marta. The stage is yours.
Thank you, Jose, for your introduction, and good morning, everyone. So today I'm going to talk about the technology we have developed within the StepUP project. And I will start from the purposes we had at the beginning of this adventure, moving then to the technical features of the technology, and eventually I will provide you some insight on the module production. So within the StepUP project, Money Group is the technology provider of the envelope system for the retrofit of the facade. So I would like to expand on the technology we have developed. Let me start first of all by giving you some background information about the goals we kept in mind during the designing process. So aim of the project was the development of the plug-and-play envelope system for the retrofit of existing facade that should have been modular, first of all, so to adapt to different building configuration, to different local scenarios. It should have been installed outside of the building envelope. Therefore, a non-disruptive and an off-site approach is essential to reduce discomfort to the residents and inhabitants, but also to reduce possible installation errors and time on site. Moreover, the possibility to make the module suitable for the integration with third-party components was also considered. And of course, last but absolutely not least, the improvement of the building in terms of energy performance was also essential. Based on these elements, we developed the StepUP modules which is a solution highly customized and also industrially produced. You can see it from the picture. The plug-and-play system has been developed by studying two main aspects. On the one hand, the anchoring system. You can see it on the right-hand side of the slide, number 1. And on the other hand, the modular elements characterized by a light steel frame structure, thermally insulating sandwich panel, and an external layer. These two aspects are in fact the key factors which allows an off-site approach to the retrofitting process, providing a solution which is modular and suitable, and therefore suitable to a wide range of existing building. In the picture, you can see the breakdown of the module. And here what we have is that the solution design was characterized by a structure. You can see at number 2, a structure composed of 3 millimeter press-formed steel profiles, connected one with the other with mechanical fixing. And then upon this structure, we have a sandwich panel that can be installed. The insulating material in this case can be in mineral wool, as the one we had in the pilots for the StepUP project, but also in polyurethane foam. So according to the requirement of the retrofitting process. Here, the sandwich panel, it's very important because it provides thermal insulation, but also stiffness to the modules. And then what we have at number 8 is the external layer, which is added thanks to brackets and profiling elements. If we focus the attention on the anchoring system, this part was deeply studied and analyzed during the project, because our aim was to define a solution that allows the 3D adjustment, so the adjustment of the module in the 3 direction, not only horizontal and vertical, but also let's say in the direction of the building. And in fact, this was important. This is important to ensure a better result, regardless of the condition of the existing wall, with the intention to provide a quicker and easier assembly of the facade. The anchoring system, represented here in the picture and in the drawings, is constituted by a 10 millimeter thick steel plate with countersink for screws, fastenings to attach the plate to the existing wall, and a front plate which allows in and out adjustment of the plug-and-play module, so with a movement of up to 50 millimeters. Thanks to the system, the 2 main connection points were studied, and it guarantees a proper connection both between the existing facade and the new envelope, and between the plug-and-play modules. If we now go, if we turn our attention now to the pictures in the slide, we can have a general idea of the modules taken together. In fact, the images represented juxtaposition of 4 modules, so 2 below and 2 above. And as I said before, the modules is constituted by different layers. In this case, the blue one is the external one in HPL, which is the material we chose for both the StepUP pilots. As you can see from the picture, the external layer covers most of the surface of the module itself, but some part, mainly at the joint, is willingly uncovered because this part will be installed on site. Why we design this? Well, the significance of this is that this choice, in our opinion, allows to reduce possible error on site during the installation phase, and increase also the level of customization of the modules. In this slide, we show an example of the installation process. This is a topic that will be further analyzed and explored in the following session. But in any case, what I can tell you now is that the plug-and-play system was developed with an off-site approach, so as an off-site solution to renovate existing building in several cases. And in fact, the solution provides a high level of standardization thanks to the industrial production processes, but at the same time, it's aimed also to have flexibility to adapt enough to existing facade. So the plug-and-play module, as I mentioned before, have two different configurations. The first option is the plug-and-play module that is completely pre-assembled, let's call it standard, and it only needs to be installed and fixed on the existing facade. In the second case, we have a partly pre-assembled module where the external layer, as we saw before, is missing, and it will be installed on site. These are the parts that we call jolly elements and are thought to adapt as much as possible to the building. The jolly elements will require exactly the same fastening methods as the rest of the cladding of the plug-and-play module, so rivets, brackets, and so on. And this is the result of a deep study and development to meet the various design and installation requirements. As I mentioned before, it allows not only to reduce the vertical joints, but also to control, adapt, prevent certain errors during the installation of the plug-and-play modules. As I was talking about the HPL material as an example of external layer, here on the right-hand side of the slide, you can see the different choices, the wide range of material that we potentially can use for the external layer. So ceramic, WPC, metal sheet, many are the possibilities. On the left-hand side of the slide, you can find some technical features of the modules. Interestingly, I would like to focus your attention to the possible dimension of the modules, which can have variable dimension, of course, to adapt to existing building. The eighth in particular can vary between 3 and 4 meters. Of course, it's important in this case to consider also transportation constraints, while width can vary between 1.3 to 2 meters. Where the facade design allows it, the plug-and-play modules will be already pre-assembled with standard modules, as I mentioned before, while other parts can be adapted on site. And as introduced before, the integration with the third-party components has also been taken into account. You will have in-depth information during the following speech by Irene Raffles about this topic. However, I can tell you that the plug-and-play modules are suitable for optional integration with other elements, such as windows, solar shading, and potentially also others. And in fact, the plug-and-play modules can be pre-assembled with or without windows, depending on the project requirements. In conclusion, I would like to outline the result of our project. First of all, starting from the modularity of the system that we have designed and produced, but also highlighting the high level of prefabrication. One great outcome from our point of view from money side is the time required for the production of these modules, which is about 20 square meters per day, in front, of course, of a high level of planning and design. And the aim, of course, was also to reduce time on site, which is possible according to the specific features of the building site and of the building. Now, I would like to leave you with some final pictures that represent the production of the modules from the steel frame to the sandwich panels to the realization of the module. We pre-assemble the brackets, the external layer, and we also create a specific packaging for this element. And then the enumeration of each element to simplify the installation phase on site. So thank you very much for your attention. I hope you enjoyed the presentation.
Thank you, Marta, and thank you for your presentation. It was very illustrative and clear. Certainly, this solution opened a new way to renovate buildings. Super, super interesting. We continue now. We move on to our last speaker, my colleague Irene Raffles, who will talk about third-party products integration. Irene Raffles is an architect from the Polytechnic University of Catalonia with a master in integrated engineering and production. She is currently the head of the production innovation department at Eurecat. She has experience in R&D projects focused in energy efficiency, construction, and development of new products from concept to industrialization. Welcome, Irene. The stage is yours.
Thank you, Jose, and thank you to all attendees for being here. Well, I will explain the StepUP experience with a third-party products integration. One of the challenge of the project was develop a plug-and-play protocol to allow to integrate third-party products with a third-party cluster in the plug-and-play facade, in the plug-and-play active system. As Marta said, the plug-and-play facade is very flexible and allows to integrate easy different products from other companies. The flexibility goes through all the profiles in the system can adjust to the dimensions of the building and allow integrate several products. The products test that the TPC and the protocol are developed and described to integrate in the project was divided in passive and active systems. The passive systems was external layer. Then external layer, as Marta shows, could vary from HPL, that is the one used in the project, to, for example, ceramic tiles and so on, high performance windows and solar protection. And from active systems, the protocol developed how to integrate PV panels, heating and cooling systems, and demand control ventilation. Sorry. The protocol developed some requirements for each of these technologies and how these technologies can be integrated in the plug-and-play facade. These requirements has been tested in 3 of them, of the technologies, in high-performance window, in blinds and sun shading elements, and in PV panels. For a high-performance window, there are 2 options of implement the windows. One is implement the windows in the existing envelope. In this case, the plug-and-play facade also need to have or accomplish several requirements to fix better the union between the new window and the facade. These requirements are mostly in the continuity of the thermal envelope, so to solve this part and to ensure there are no thermal breaches. So it's need to install a perimeter frame, and this frame has to be some kind of thermal insulation to ensure there are no thermal breaches between the new performance window and the new layer of the facade. This kind of installation has been tested in the Hungarian pilot. Here you can see how the plug-and-play facade is without a window, and how this is integrated in the final window, and that we need to put a frame to ensure this complete sealing of the window with the facade, and also avoid the thermal breaches. Another kind of integration of the TPC window, of windows, are installed and implemented in the sandwich panel. In this case, the requirements are higher because we need that the superstructure of the window or the frame of the window must be compatible with the sandwich panel. So we need to fix this window in the sandwich panel, and all the mechanical fixings has to accept that. And another, we need also put a perimeter frame for the outside to seal with a window hole, and we need to seal the air chamber and with another perimeter frame for the interior, and also to finish with an optimal interior finishing. We test this kind of integration in the pilot of Pamplona. And here you can see how the panel is complete with the window, and how this panel after that is installed in the pilot. Another product that we tested is a Venetian blind. And there is also two types of integration of this blind. One type of integration is when the window is located in the existing envelope. This brings us that we have more space to include the Venetian blinds, and we are more flexible to put the blind where it's interested. So the requirements here is that the provider of the blind needs to provide the systems adaptable to frame sheet and easy to fix mechanically to that sandwich panel. We also need to close with a frame all the facade, and we need to ensure all the sealing from the panel to the existing window or to the new window. And also there is a kind of visual aspect that the sun shading elements has included in the window opening, so the final window hole it's smaller than the existing one. And another system to include this Venetian blind in the product is the one that it's needed when the window is located in the sandwich panel. This brings us that we have less space to put this Venetian blind, and we need to fix it mechanically. That the fixture it's more difficult to fix to the sandwich panel, but it is also possible. And we have also the hole smaller. The Windows hole is appreciated as smaller than the existing one. This kind of integration has been tested in a prototype done by Mani in their facilities in Isopan Tarragona, and here you can see the final integration and how the Windows hole or the Windows opening is reduced with this situation of the Venetian blind, but at the same time it's quite well integrated and accomplishes with the aesthetics of the building. And finally, the last technology that we test to integrate in the plug-and-play facade is the PV panel. PV panels, most of the PV panels from the market, or most of the system of building integration photovoltaics, also there are systems of anchoring and profiles that it are easy to integrate in the plug-and-play facade, because substituting the profiles to fix the exterior HPL external layer of a plug-and-play facade, it's easy to change these profiles for the PV panels profiles and fix this new the PV panel as an external layer. The superstructure should be able to be attached to a sandwich panel with the brackets, with the brackets developed by Mani. The anchoring systems need to fit into the air gap, and for sure we need to install the ground wires and to design better the ground wires, how it goes, to ensure the electrical safety. And that's all of the this is how the detail is solved in the case of Pamplona pilot, and how the PV panel are installed. You can see here that the planarity is accomplished. You can see that adds these different elements for fixing and different profiles, but we can also, the system is so flexible to ensure that planarity will be achieved. And that's all from my side. Thank you very much to all of you.
Thank you, Irene. Thank you for your presentation. Clearly, this part is an opportunity for manufacturers to consider and rethink how to adapt their solutions to a new construction model. Super interesting too. Thank you. Now we will proceed to the question round. You can ask our three speakers any doubts you have about their presentations, and they will do their best to respond. If anyone has any questions, now is the time. We see that we have some questions yet. First one for Marta Lupi. Do you see any difficulties in the spread and use of this technology on the market? If so, what do you think might be the biggest challenge?
Okay, so as far as I can understand, and from the experience we have in innovative process and project, I think that the biggest challenge would be the lack of knowledge related to the off-site approach. So generally speaking, I think that new approaches, new solution can always scare a bit people when they're not fully understood. So therefore, I think that dissemination about the benefits of the off-site approach, about the feature of new solution, about the installation method is crucial if we really want to break into the market and change the retrofitting approach.
Perfect. Thank you, Marta. Another for you. What is the role of architects and designers in the deep renovation challenge? And what would you suggest to architects and designers interested in your solutions?
Okay. Personally, I think that architects and designers have a big role, a fundamental role, I would say, in the challenge of retrofitting the existing building stock in Europe. So if they really can understand the potential of the off-site approach, I would underline the importance of putting as much effort as possible in the preparatory phases. So the 3D survey of the building, the designing phase, the use of BMI elements in order to reduce time and cost on site, and also mainly the level of uncertainty that a building, construction building site always have. I hope my answer
Okay,
is
thank you,
clear.
Marta. Super clear.
Thank you.
Next one for Irene. Which are the main benefits of integrating third-party products in the facade components?
Well, I think the main benefits is that to achieve the goals that Marta said of reducing time on site, for example, integrating the elements, the sun shading elements, the PV panels, or the windows this drives to, for sure, reduce time on site for one hand, and on the other hand, for sure, also to increase the safety for the workers. Workers can install their components in a good conditions, well positioned, without cranes and so on. So the workers are more safely, and this also brings to better installation, because they can work with all the tools and all that we need, that they need to install perfect the components. So I think these are the two main benefits: safely and reduce time on site.
Super clear. Thank you, Irene. We have more questions. Thank you. For Zoltan, how can the heat tank thermal battery be integrated with renewable energy sources?
Thank you for the question. So basically, we call our technology heat tank thermal battery because, for example, when we would like to integrate with the PV source, the heat tank is a good alternative compared to the electrical batteries. Because heat tank doesn't contain any problematic parts, poisonous material, rare earths, metals, and this is a long-lasting solution. The integration itself happens by making connection to our control system. It means that, for example, in a PV system, if we can see or get a signal that there would be overproduction from the PV side, and for example, the utility is not buying back the electricity or doesn't pay that much as we would like to expect, it's a good idea and good strategy to start a charging of the heat tank. This will result in increasing the power of the chiller or heat pump in the system. So basically turning the excess electricity to heating or cooling energy. And later on, when the building needs this cooling energy or heating energy, but the sun is not shining anymore, so we don't have available electricity from the PV source, heat tank is able to give back the pre-stored cooling or heating energy. This is an indirect integration, so basically we will not produce electricity, but when we are providing cooling or heating to the building, the cooling or heating system will not consume that amount of electricity. So it's an indirect integration, so we can support all of these kind of sources.
Okay, thank you, Zoltan. We have two questions more. For Zoltan now, another. Can you provide bigger systems as well?
Yes. So basically, what I showed in the presentation, and what we also presented in the StepUP pilots, we have standard size systems, and for bigger needs, we are able to provide more storages together. So basically, in parallel, they can be connected. If more capacity or power is required, we can provide more. This is also the, let's say, connection points with the electrical batteries as well. If you need higher need, or if you have higher needs, we can provide more storages together. They will act like a system. So all of the system elements will be the same. You won't need more pumps or more electrical or controllable valves or sensors. You will just have bigger and bigger storage element in the system.
Okay, Zoltan. Super clear. Okay, thank you. Thank you for your answer. The last one for Marta. Well, what was the reason for selecting a sandwich panel for the insulation instead of other type of solutions to integrate the insulation? Was the disassembly and reuse or recycle potential of the insulation panel considered?
So the main reason is that Isopan is a manufacturing company which produces sandwich panels. So first of all, this, and we have a very strong experience and expertise on this type of material, on the insulating property and feature of this kind of elements. And then, of course, there is also the reason you mentioned before, the disassembly is possible in a very easy way in comparison to other type of material.
Super, super, great, great. We have another question. Thank you all the attendees for your contributions. Is for Irene. How is the maintenance of active technologies solved once they are already integrated? Are the technologies and their connections accessible?
Okay. Sorry. The maintenance is quite similar of the PV integration integrated in facades without being in a complete plug-and-play facade. Okay, that the maintenance has to be from outside, and the systems allows to disassemble and assemble easily the PV panels to, if, for example, remove them if it's broken.
Super, super clear. Thank you, Irene. I think that we don't have any question more, no questions more. Thank you. Thank you, all the people. We are going to conclude session 2. Thanks to all the speakers and attendees. We will continue with the event, and I had back control to Miguel.
Okay, thank you very much. We will now start session. And in session 3, we will present the deep renovation projects pilots of the StepUP project. But I need to swap from session, so I'll be back in like 15 seconds.